Find the location of the local minimum and local maximum of the function. So here I have a cubic function, and I want to find out where it has minimums and maximums. The way we go about this is, first off, we know that local minimums and local maximums, these only occur at critical numbers, or critical values, whatever you want to call them. And these are values where the first derivative is 0 or undefined. Now this is a continuous curve. We don't have to worry about any undefined values for our first derivative. So, and actually it's a smooth continuous curve, they say. But anyway, we will find the first derivative as the first step here. So this would be 6x squared minus 72x plus 192. Now, that is a polynomial that we need to set equal to 0 and try to factor. One thing that might be helpful here is it appears that this potentially might, the coefficients might all be divisible by 6, and that would reduce our work quite a bit. Let's see. Oh, great. All right, so I can divide everything through by 6 and make this x squared minus 12x plus 32. And this should be factorable. Let's see here. And let's see, 32, we could factor into 4 and 8. And if those are both negative, that would be multiply to negative 32 and add to negative 12, so that's great. So that means I have critical numbers at 4 and 8. Now, those critical numbers are important. They give us a place where local minimums and maximums can occur. But we don't know yet if these actually are minimums or maximums without further testing. So the further testing that we need to do is determine if the function is increasing or decreasing around these critical numbers. Because if I go from an interval that is increasing to decreasing, then that critical value that occurred had to be a maximum. So that's the sort of thinking that I'm going with. What I will do in order to determine if I have an interval of increase is take test values within each interval. So 0 is a nice easy one in this one. And how about 5 and 9? I generally pick the smallest ones that will work. And I determine if the first derivative is greater than 0 or less than 0 at each of these test values. Because if it's greater than 0 at any of these test values, that means the function's increasing on that entire interval. So let's see. If I plug in 0, that would be negative 4 times negative 8. And I'm using this form right here because it's an easy form of the derivative. Although it was after I factored out 6, and that actually wouldn't be a problem because here's the thing. That would be equal to this, which would be equal to this right here. And 6 is a positive number, which isn't going to change whether the function is positive or negative. So that's fine. This will work. All right, so this multiplies to 32, which doesn't really matter what the number is. It just matters that it is positive. All right, at 5, 5 minus 4 is 1. 5 minus 8 is negative 3. So we have a negative values there, so we're decreasing on that interval. And lastly, 9. So 9 minus 4 would be 5, and 9 minus 8 would be 1. That multiplies to 5, so that is positive. All right, so we go from intervals that go from increasing to decreasing. So that means this value has to be a maximum. And then we go from decreasing to increasing. So this has to be a minimum. All right, so what we say is we have a relative maximum of blank at x equals 4, and we have a relative minimum of blank at x equals 8. And the reason I'm putting blanks in here is because I don't know what those actual values are yet, but I can easily find them by just plugging into the function. So plugging those values into the function, I think what might be easiest if I put the function into y1 and use a table. So 2x cubed minus 36x squared plus 192x plus 6. And if I go to my table here, I just want to evaluate this at the point 4 and 8. So 326 and 262. So the relative maximum overall is 326, and that happens at x equals 4. And the relative minimum is at 262, and that happens when x is equal to 8.